difference property going from here to here. Okay? But from there to there, all I did was I divided this, did that division, which gave me that. Okay? And then I did this division, which gave me that. Is everybody with me? It's like saying that 3 plus 5 over 2 is the same thing as 3 over 2 plus 5 over 2. Right? You can break the division up over the plus sign. Okay? And kind of distribute it to the 3 and to the 5. You guys with me? It's the same concept, exactly the same concept. Okay? Right, so now I know how to go from there to there. And then I know what is the limit of half as x goes to infinity? Does half depend on x? Is the x variable in here? Then it doesn't matter what x is going to. I don't care. It doesn't depend on x. So my limit has got to be 1/2. Okay? So that's where this 1/2 comes from. And then from here, from the limits that I just gave you a minute ago, do you see that this is going to 0? Yes? Okay, even if you don't remember the rules, you can think about it. If the denominator is getting bigger and bigger and bigger and bigger and bigger, the answer's got to be smaller and smaller and smaller, and the smallest number you know is 0. Okay, you guys with me on this? Are you guys awake? Okay, so this gives you 1/2. Your answer is 1/2. You guys okay? Yeah. Okay, thank you, Henry, for being so cooperative.
So is it the limit of 1 over 2x equals 0, but the other limit equals no x equals 1/2?
That's right.
Is that simple?
That's simple. Okay, example 2. So if you see, by putting in infinity for x, you're going to get infinity over infinity, which I have no idea what that is. I have no idea what that is. Sorry? No, because your infinity is different from my infinity. Okay, so now the question is, how do I massage this so that I don't have infinity over infinity? Well, this is kind of tricky, okay, so let's go over it. Notice how I write the limit over again, okay? Already there's finals for the seniors. I changed my mind. Hey, you know, I'm liable to. Sharik's kind of pushing for finals for seniors. Okay, so the trick here is I'm going to divide the numerator by x squared, the whole thing. And you'll ask me why I want to do that. And all I'll tell you is that I feel it. In my heart. Okay? Right? So whatever I did to the numerator, I did to the denominator as well. That's pretty good. Okay? That's good.
You're divided by x squared?
Yes. So then this becomes equal to limit x goes to infinity of minus 2 over x plus 3 over x squared over 3 plus 1 over x squared. I'll show you two ways of really analyzing this problem, okay? I mean, a lot of these limit problems is a question of really what skills do I use to really answer the question. It's not just a question of following rules, okay? Although this method that I'm showing you is following rules. So what happens when x goes to infinity? What happens to this guy? And give me a number, okay? Don't just say smaller. This is a math class. 0. What happens to this guy? 0. What happens to this guy? Stays the same. What happens to this guy? What do you think the answer is? Okay? So that's one long way of doing it. Here's another more intuitive way of doing this problem. Okay? Now, if I say that x is getting huge, absolutely massive, what do you think 3 is compared to massive? Small. It's, it's like my salary compared to Bill Gates' salary. All right? Insignificant. Okay? Sorry? What? No. Wait, no. Do I wish? Would I want all that money that Bill has? What would I do with it? Well, he's doing that, so what? Okay, big deal. So you go give away. Oh, you know what? Mr. Lazard gave me this statement yesterday. Really interesting. So this is an army poster from the 60s. It's a tongue-in-cheek, okay, a sarcastic poster from the 60s. So it says, join the army. Go travel the world. See new people. See different people. Then kill them.
Wow.
Yeah, what does that have to do with Bill Gates' money?
Yeah, I know.
Oh, well, what it says is, what's the point of sitting in Seattle in a mansion that's 37,000 square feet mansion and then just handing out money to people?
When he died, around his kids, like all of his money is going to charity. His kids get like less than a percent.
1% is like
I know,
500 million
Yeah, no,
or even
it's
more.
Than a percent. Like he's giving all of it away. Like how cool is that? Like,
That is extremely cool. He's one of
like,
the...
yeah, their kids are still giving a crap ton of money, but like less than 1%, and like everything else is going to charity.
I mean, he is... You got to admit that Bill Gates has single-handedly changed the philanthropy in this country. Single-handedly. Changed the whole dynamics of how people give money. He's what? Duh. Yeah. Yeah, he's doing it for ulterior motives. Yeah. Okay, so again, we're not done here. Okay, so if you take a look at x going to infinity, then what is this plus 1 compared to infinity? Insignificant. Scratch it out. Insignificant. So then this becomes limit x goes to infinity of minus 2. And then can I cancel one of the x's? Now you know what the answer is. What happens when x becomes small, huge? The answer becomes this is equal to 0, which is the same thing that we got. So two alternative ways of really looking at it. Okay, one a more intuitive way, and the other a more procedural way. All right, more examples. I don't know if I do negative infinity. It shouldn't matter, frankly. Shouldn't matter.